Hey everyone, welcome back to the channel. In our last video, we explored OpenAI's new Swarm framework, showing you the ins and the outs, running some examples, and doing a few evaluations. If you haven't seen that one, definitely check it out because today we're going a step further. In this video, we're going to be building something even more powerful, a Solana trading agent that can totally change the way you approach automated trading. We'll be creating this tool that tracks trading pools, executes real-time buys and sells, and manages your wallet balances, all while keeping an eye on your token accounts in one streamlined agent. This setup is something you can expand on and make it more your own. Keep in mind though, it's going to need some thorough testing on your end to make sure it aligns with your goals. And remember, never trade with anything more than you can afford to lose. Stick around to the end and trust me, you don't want to miss any part of this. By the time we're done, you'll have everything you need to start putting this agent to work on Solana. So let's dive into the video. Okay, so there are a few things that we're going to have to do before we start getting into the code. So the first thing is I created this repo. It's called Swarm Async because right now Swarm doesn't allow asynchronous functions. So I had to edit their code so that way we can make it asynchronous. So that'll be found on my GitHub if you guys want to use it. And I'll also have it below in the Patreon. It'll be in the folder. Next, we're going to need an RPC. So I decided to use Helius for this. You guys can use whatever provider you guys want. Helius does offer a free plan with 500,000 free credits, which will be more than enough for what we're trying to do here. So next, we're going to need the Birdeye API key. So this is going to allow us to get the price of any token. So all you're going to have to do is just visit docs.birdeye.so and then you'll log in. You can obtain an API key. It's all free. So unless you're using a very large amount of requests, then you'll have to get on a pay plan. All right, so we're also going to be using the Gecko terminal from Gecko. This will allow us to get the trending pools. All right, and the last thing we're going to be using is Jupyter's API. Jupyter is a swap on Solana. So this will allow us to get the quotes and be able to get the swap instructions so that way we can use their aggregator. You have the choice to use their API, which is rate limited, or you can look through their documents and self-host it yourself. All right, so this is the main.py. In here, we're going to be running our loop. So we have the run demo loop. We are importing it from the Swarm Async. And then we also have our agents, and we'll start off with the account manager. And then we're going to be streaming out the outputs. All right, and this is our agent file. In this, we have the account manager, and we have the trader. Down here, we have the functions that we're calling. And then over here, we have transfer to trader and transfer to account manager. So that way it will transfer to them. And over here, we have the functions. We're just appending those into the array. All of these could be done underneath one agent, but I wanted to give you guys two so you guys can see how the multi-agent framework works. All right, so this is the system prompt for the account manager. So in here, you guys can read through. It just gives it some more information. Tells it that it's going to be managing the account, a little bit about the rent fees. And then we talk about the functions, get token price, get token accounts, get trending pools, and transfer to trader. Just giving it some more information about what we want out of it. Over here, we have the trader prompt. Talk about the order that we want the trades to go in, the min and max trade sizes, everything that it should do, like the checks that it should make before placing a trade. And then down here, we have the functions as well. All right, so this is the trading.py file. So we are pulling in the private key, which we put in our constants. And then down here, we're getting the bytes from it and then setting the key pair. Then we are setting the async client. This is so we can interact with the blockchain. And then here is the Jupyter client, which we'll go into that next. So what we're going to do is we're going to get the wallet balance with this function. And then this function right here, we get the trending pools, and we get this from the CoinGecko terminal. There's no API key needed for that one. And then we can get the token price from Birdeye. And then we use our API key for that. And then we define Solana as the chain. And then we place a buy order through Jupyter. So we're passing in the key pair, we're passing in the token address for Solana, and then we're passing in the token address of the mint that we want to buy. And then the amount of SOL, and then this is the decimals of Solana. Then over here is the sell trade, which is the exact opposite. So our token address goes first, and then Solana is the output. And then this is the amount of tokens. Then over here we have the get token accounts, and this gets all of our token accounts as well as the decimals and some information for us like the balance. So here's our Jupyter.py. There is a Python library you can use for Jupyter. It's not the official one. It's not updated, so I decided just to use requests. So over here we have our error codes. You can find this on the IDL. And then down here we have our Jupyter class. So we have the swap. And then with the swap, it gives us the instruction and everything. So first we pull in the quote. And we put in our input mint and output mint, the amount, the swap mode is exact, restrict intermediate tokens. And then we add the max auto slippage, which is 3%. And then what we're going to do is we come down here, we have our swap URL. So if you're self-hosting, you would change these URLs where it says quote API jup.ag. You would change this to yours. Over here we have our quote data. So this is what comes out of the quote URL. We need to pass that in here. We need to pass in our public key, which we pass into swap. And then down here, we put unwrap sold true, use shared accounts true, as a legacy transaction false, dynamic compute limit true, and then our max slippage. And then over here, we edit the prioritization fee lamp ports. So this is the max lamp ports, and the priority level is set to high. Then down here, we get our swap response. Okay, so over here, we have our place order. So what we do is we pass in the key pair, our input mint, output mint, amount, and decimals. And then we have our async client right here. And then this is our retry logic as well. So we get our transaction data from the swap. Then down here, we put into a raw transaction, and then we sign it. And then after we sign it, we put it into a versioned transaction. And then over here, we have our transaction options. So we set our pre-flight commitment to process. And then over here, we're going to send the raw transaction. And then this will go, and then what we'll do is we're going to be checking for the get signature statuses. So when this comes back as confirmed, that means it hit the chain and our transaction got picked up. And you'll see that down here, confirmed, processed, and finalized. And then you'll get the link to it as well. So with Jupyter, you can change any of the quote query parameters. So they have like the slippage, the swap modes, the dexes, excluded dexes, only direct routes. Like you can play around with all this stuff to set it up exactly how you want. And then same with the swap as well. Like with the prioritization and fee lamp ports, you can use Gecko if you want to, and send with that. So with Gecko, you're tipping the validator an extra fee. This allows your transaction to be included inside of their blocks. Alright, so we'll run python main.py to get it started. And then first thing we'll do is we'll check the wallet balance. And you can see it runs the first function and it gets our wallet balance, and this is correct. Okay, so we're going to ask it to get the token balances. Right now we have one token in there, which is OR, and we have 0.01 of that. So let's just ask it to buy some more. We're going to ask it to buy 0.001 of that token. And sometimes it takes a little bit because it's running in a loop. So what it's going to do is it's going to let us know that we don't need to pay any additional rent fees, pass it along to the trader, and the trader is going to place the buy order. Once the buy order is done, we'll get the link to where we can see the transaction on the blockchain. Okay, we can see that it was successful, and we can view the transaction on the blockchain now. Alright, so you can see that the transaction went through, it was successful. We swapped 0.001 SOL for 0.005 OR. And then you can see like the intermediates that I had to go through. And that's what Jupyter's for. It aggregates and goes through all these pools to get you the best price. If you come down here, you can see our priority fees. And then this is just all the transaction details in here. Alright, so now we'll get the trending pools. So since the trader does not have access to this, we have to ask it to switch back to the account manager. Alright, so now that we're back on the manager, we can ask it to get the trending tokens for us. Alright, so on here it gives us our top 5. So we have BOMC-Sol, we have Loose, we have Terminal, Republican, and Goat. Goat was actually created by, supposedly, an autonomous AI that's running. You can find it on Twitter at Truth Terminal. So another thing is it gives you the rating and the reasoning, and then how much SOL you should use to buy. So this one, I gave it a 4, said high volatility, significant price drops recently, so it doesn't want to buy any of that. This one, it gives a 5 out of 10. This one gives a 3 out of 10. This one gets a 6 out of 10, and then Goat at the bottom gets a 7 out of 10. With the strong market cap, consistent trading with a slight downtrend, but could reverse. So if you wanted to run it in autonomous loop and you had these agents running, they could possibly work and trade and find good tokens. Alright, so what we're going to do now is we're going to ask it to sell 0.02 of the OR token that we hold. So it looks like it hasn't updated the balance completely. Okay, so now it's updated, has the correct balance. Nice, we got the transaction back, and now we can check it on the blockchain. Alright, so we can see that it swapped 0.02 OR back to 0.003 SOL. And in here it had the intermediate tokens, and then you can see the fees down here as well. Alright, so now you can see that it was able to place trades, buys and sells, was able to get the trending pools, and check your token accounts and wallet balance. So that's it for this video. If you guys enjoyed it, please drop a like, comment, and subscribe, and all the code will be below my Patreon.